Welcome to a new problem solving session, and with this problem we are going to start taking problems of dynamics of rigid body rotation. So this is the first problem, a bit weird, but we have a problem here at hand. And the statement of the problem simply says that the pencil shaped as a regular hexagon can roll down an inclined plane. See the figure, this is a side view. Yeah, of course, I can understand this. And the first part of the problem statement is the structure is at rest and we gradually increase the angle alpha which this plane forms with the horizontal. At what angle of alpha will the structure roll without slipping? I think this is pretty simple. And the second part of his statement says with what minimum value of linear velocity will the structure roll down the inclined plane for an indefinite period without slipping for a given value of alpha. So you don't need to do anything with alpha. And also there are instructions like consider the impacts of the corner of the pencil on this plane to be inelastic. So collisions are inelastic, and I know that corners are going to struck the inclined plane, and these impacts must be inelastic. And the radius of the pencil being r, this is to solve the second part of the problem. So we are going to solve one by one. Let's take the first part, and to solve the first part and second part of the problem, I have drawn a picture, and if you can see here that the structure will structure will roll at an angle such that the center of mass, which is I guess is here, is above the support point A. This is the support point A, or to the right of it. मतलब इस स्ट्रक्चर को रोलिंग स्टार्ट करने के पहले इसका सेंटर ऑफ मास सपोर्ट पॉइंट के ऊपर होना चाहिए. दिस इज अ सिंपल थिंग, वी नो समथिंग. इफ यू हैंग समथिंग फ्रॉम द सीलिंग to for the body to stay in equilibrium, the center of gravity of the body should lie beneath or below the point of suspension. ऐसा केस तो होता है आई थिंक जब हम किसी चीज़ को हैंग करते हैं. यहाँ भी वैसे ही शुरुआत होगी. ये जो सपोर्ट है, सपोर्ट पॉइंट एट द इंक्लाइन प्लेन, इसके ठीक ऊपर, जस्ट एबव द सपोर्ट पॉइंट ए, द सेंटर ऑफ मास ऑफ द बॉडी शुड बी टू स्टार्ट रोलिंग. And I guess in this case, this angle, since it is a regular hexagon, so phi is simply 60 degree. Pi by 3, whatever you wish to write, 60 degree. And in this case, in this formulation, in this situation, when the inclined plane has been tilted up, this angle is going to be alpha, and alpha is nothing but strictly this is pi by 2, because we are dealing with equilateral triangles. And you can see yourself that answer to this question is that alpha should be greater than equal to 30 degree. So this is the answer. Alpha should be greater than equal to 30 degree to start rolling. To just start rolling, it should be equal to 30 degree. And if you just tilted a bit bit of the angle, that is called a very small angle above 30 degree, then it will start rolling. Any angle above 30 degree will make the structure roll down. So this was the answer to the first question. Now we are going to solve the second part of the question. And second part, or the statement of the second part of the question is, with what minimum value of initial velocity will the structure roll down the inclined plane for an indefinite period without stopping for a given value of alpha? So this is ready to roll, and in this situation we know this is ready to roll, and we have to take impacts with the corner as inelastic, and radius of the pencil, that should be something like this or this, that should be equal to r in our case. So how can we solve it? The problem is, let we give some velocity, and we can only give the velocity because slipping is prevented here, so there is no slipping happening here. So we need to give this a velocity v1, say v1, in a direction perpendicular to the line OA, and we give it, and then we'll start moving around this point A in a circle, and suppose it reaches here. By moving, it reaches here, and its velocity here will be something v2. So we need to find out what is the value of v2. So I gave it a velocity v1 at the initial position, and this line OA rotating in a circle come to this position. So this position I would like to name it O dash. So OA becomes O dash, and now it has gained a velocity v2. So we need to find out what is the velocity of value v2 first. v2 is of course it's going to be since there is no slipping, so friction is not going to work here, and v2 is going to be nothing but under root v1 square plus 2gh. But what is the height? What is this value of h? This is basically the difference between heights. H is the height. The pencil or the hexagon, the height it covered in vertically downward direction. I know height has been decreased, but what is this decreased height h? You need to find out by thinking. I have given a thought, and I know what the value of h is going to be, but let's see. If you are convinced enough, you will find that h is basically this height, basically this height. H is basically this height. Let's name this position A dash. So H is going to be this height. यही height ये नीचे आया है, इसका center of mass, center of gravity of the hexagon. इतना ही distance, ये distance H है. हालांकि मैंने इसका नाम रखा हुआ था A, इस पॉइंट का थोड़ी देर के लिए मैं भूल जाता हूँ, और इस हाइट को, इस पिक्चर को मैं क्लियर बनाता हूँ. दिस इज़ द हाइट h वी आर लुकिंग फॉर. ये नीचे आया है, एंड यू कैन से हियर दैट दिस एंगल इज अल्फा, एंड दिस इज ऑफ कोर्स रेडियस r, दिस इज रेडियस r, दिस इज एंगल phi, and so I guess these two angles are also phi, because it's a hexagon, so this angle is also phi. So this length is also r. If it would have been another situation, another figure, then there must be some kind of difficulties. Or if this is not the hexagon, it is something else, then how will you find basically, if this is not hexagon, then how are you going to find this angle? You must know it would have been something phi. But if this is not hexagon, this angle is something else. But these two angles must be same, these two angles. If this angle I say beta, so this angle will be also equal to beta, and this, what will be this length? I don't know r dash in that case. So you are going to get something like here is this r dash beta, you know, here phi plus 2 beta must be equal to 180 degree. So 2 beta, you would like to write phi minus pi minus phi, and so beta becomes pi by 2 minus pi by 2. And then in that case you can write as the sine formula, and the sine formula becomes r by sine beta equal to r dash by sine phi. And that means I could have written r upon sine pi by 2 minus phi by 2 equals r dash sine phi. And in that case r dash will become r sine phi upon cos pi by 2, and I can again write it r sine phi as 2r sine phi by 2 cos pi by 2 divided by cos pi by 2. Cos pi by 2 is not equal to 0, so r dash become simply 2r sine phi by 2. And in that case, since this length is r dash, so this h would have become h equals r dash sine alpha. You can see the picture again. This length, if this length is r dash, then h will become r dash sine alpha, and this length is going to be 2r sine pi by 2 sine alpha, and like this. But this is not the case with us. We don't have a different r dash, we simply have the r. So this h in our case is simply r sine alpha and nothing else. And in that case, in this case basically we have the velocity v2 equals under root v1 square plus 2gh, where r becomes r sine alpha, and alpha is equal to 30 degree, we know, and we can do things accordingly. But look, here it is v2, this is v2, but you remember the condition that the collisions are elastic. Collision of this hexagon or the pencil, the collision of the corners of the hexagon with the inclined plane are inelastic collision. So I guess in this case it is going to lose the velocity in this direction. I think the next collision happens here. Yeah, next collision happens with this line, the final collision after tipping for the first time. So this component of velocity it will lose along this line. If I name this a dash was already there, so if I name this point a dash, so v2, the component of v2 along a dash, o dash a dash, it will be damped. Simply it is going to lose that velocity, so it will have a velocity perpendicular to the odd acid as only. And there are many perpendiculars. If this angle is phi, this angle is 90 minus pi, so these two lines are again perpendicular, so this angle is going to be phi. So let's name this velocity v3, and to maintain the condition of this problem, v3 should be equal to v1, because remember the statement of the problem. It said with what minimum value of linear velocity will the structure roll down the inclined plane for an infinite period without stopping for a given value of alpha. That means v1 should be equal to v3, and then you can solve the problem as well, because I earlier got that this v3 is equal to v2 cos pi. So if this v3 is v2 cos pi, and this is v3 is v2 cos pi, and this must be equal to v1. So we have a relation like v2 equals under root v1 square plus 2gh something, and if we multiply with this cos pi, then we are going to get v2 cos pi equal to under root v1 square plus 2gh multiplied by cos pi, and then put v3, this is your v2, and v1 is also equal to v3, that is v2 cos pi again. And you can solve this problem by putting all those things. You can solve the problem like that means this thing becomes v3, and v1 is again v3, so this becomes v3 square plus 2gh. Put the value of h, that is in case r sine alpha, I think h is r sine alpha in this case. H is equal to r sine alpha in this case. So put here r sine alpha multiplied by cos pi. Make a square then. v3 square equals v3 square cos pi plus 2gr sine alpha. This is not basically cos pi, this is cos square phi multiplied by cos square phi, and you will get your v3 or v1, whatever you need it to. So I think it becomes v3 square 1 minus cos square phi equals 2gr sine alpha cos square phi, and so that it becomes v3 square equals 2gr sine alpha cot square phi. Cos square phi divided by sine square phi is cot square phi, and this is your result finally. 2gr sine alpha under root cot square phi, sorry, this is going to be cot square phi, and you will get your result. However, in the other case, if this picture is not a strictly hexagon, we may have a different answer. H will be different, and phi will be different, alpha will be different, and you can get your results. So I saw a problem like this somewhere. So I tried to solve it, but I couldn't understand the problem at the very first moment. Then I gave it a thoughts after thoughts, Finally, I was able to understand the content of the problem, and then I tried to solve it. And this is the problem. Thank you very much for watching.